Okay, so today we are, before we get started, I want to go over the warm-up. So do lines NK and RP intersect? First thing we need to do is we need to find NK. That would be this line right here. And we see that it is on plane X, okay? The reason that we can tell that it's on plane X is because when the plane W, that's this one right here, when the line is going in, when you see the line NK where plane W is, there's a dotted line. So if you look, let me erase this right here so you guys can see it. So right here, where plane W is, where our line is supposed to be, it's a dotted line because it's behind. So we know that it has to be on plane X, okay? So it says, does that line and the line RP, that's this line right here, do they intersect? And the answer is no, because they would have to intersect somewhere on this line where the planes intersect, where plane W and plane X intersect. And that would be on line JK, which they do not intersect. They have NK has the intersection point of K, and RP has the intersection point of L. So they do not intersect. And you could have put that they are on different planes. Okay, that's number one. Number two, are points NK and P coplanar? So let's erase what we did before. It's not erasing very well. All right, so the points N, K, and P. N is here, K is here, and P is over here. Well, N lies on plane X. K lies also on plane X and plane W. And plane P, and point P lies on plane W. Now, this is a little bit confusing, but they are coplanar, okay? Because any 3 points that are non-collinear, and these are all non-collinear, N and K are on the same line, but P is not on that line, then they are on the same plane, so they are coplanar. Okay? Now, if it said, are N, K, Q, and P coplanar, then the answer would be no. Okay, because Q and P lie on the plane W, and N and K lie on, well, K lies on plane W, N does not, N lies on plane X. Okay, so if we were to say those 4, are they coplanar? The answer would be no. But remember, any 3 non-collinear points do lie on the same plane. Okay? All right, number 3. What is the intersection of plane X and plane W? So they intersect at a line. Their intersection is a line. And that line is line JK. It's right here. Okay. Plane X is this one that I circled. That's this one right here. And it intersects plane W at that line. Okay, all along there. So that would be line JK. And is point Q on the same line as L and M? So point Q is all the way over here. Is that on the same line as L and M? No. Oh, on the same plane, sorry. On the same plane as points L and M? No, because M is on plane X, L is also on plane X, so Q is not on the same plane. Okay, Q is on plane W. Q is on plane W, L, and M are on plane X. But at the same time, guys, don't forget that L is also on plane W because it lies on the intersection, okay? So it's really because M is on plane X, not W, right? All right, let's move on. Doing chapter 2, section 4, properties of algebra. Okay, so today we are going, should be a bit of a review, that we're going over the properties of equality, okay? And you guys may not remember these specifically, but you're gonna remember the gist of it. So the addition property of equality says that if A equals B and C equals D, then A plus C equals B plus D. And that's basically saying that, like, if you were solving for an equation, right, and you added 7 to both sides to cancel something out, that is the addition property of equality. Because the reason that you do it to both sides makes it so it's equal. So I want you guys to write the addition property, draw a plus sign so you know that it's addition, and these are same thing to both sides. Okay, the subtraction property, that's where you subtract the same thing from both sides. So if C equals D, then A minus C equals B minus D. That would be if you were subtracting 9 from both sides in order to get your variable alone, okay? Multiplication property of equality, that's where you multiply both sides by the same thing in order to get something alone. So that's where, like, let's say we were taking C, we wanted to multiply both sides by that C in order to keep the equality, okay? And then the division property. That's just where you're dividing both sides by the same thing, okay? All right, properties of equality, some more. So we've got the substitution property. The substitution property of equality states that if A equals B, then either A or B must be substituted for the, or may be substituted for the other in any equation or inequality. So if 2A equals 10, then 2B equals 10, okay? You can just substitute B for A, or you could also substitute A for B, and it would be the same thing that you're just substituting in. So if it told us that A was equal to 5, then you could just substitute 5 in for A, and you would get 2 times 5 equals 10. That's another example of the substitution property, all right? The reflexive property is just A equals A, so that means that any number is equal to itself. The symmetric property, that's if A equals B, then B equals A. You could think about it as a reflection. And this is our line of symmetry. You're just switching the order over the line of symmetry. Okay. The transitive is if A equals B and B equals C, then A equals C. This is just like the law of syllogism. And you're just joining the statements. Okay, now the transitive property, I want to give you guys an example. So an example is if x equals 3 and 3 equals y, then x equals y, okay? All right, the distributive, okay, so that's where you distribute the value outside of the parentheses to what's inside, and we would get AB plus AC. And the distributive difference, so that's where we distribute, and there's a negative sign, so we would do AB minus AC, okay? You guys should know all of these, and we're moving on. Properties apply to angles and segments, okay? So for this one, the reflexive property is true for numbers and variables. So I want you guys to write that down. Okay, and so DE equals DE. And this is now true for segments and angles. This was basically when we said x equals x, so you can say that segments are equal to each other. This one's pretty self-explanatory. The symmetric property, okay? So that's where if DE equals FG, then you can say FG equals DE. You're just basically thinking about it as a mirror of itself, okay? So you can just write it in the opposite order. So angle A equals angle B, then angle B equals angle A. And the transitive, this is where it has the third piece, okay? So if AB equals CD and CD equals EF, then we can just take out the CD and just write AB equals EF, okay? If angle A equals angle B and angle B equals angle C, we can take out angle B and just write angle A equals angle C. All right, and moving on. So example 1, justify each statement with a property from algebra or a property of congruence. So if AB equals CD, then CD equals AB. This is the symmetric property of equality. Okay, I'm gonna write an equal sign to represent equality. The reason we knew it was symmetric is because this CD is repeated and all you're doing is switching the order of which one comes first before the equal sign, okay? This next one, we are distributing that 3, that is the distributive property. You could also put distributive property of addition, okay? And then if 2a plus b equals 24 and b equals 4a, then 2a plus 4a equals 24. This would be considered the substitution. Because all you're doing is what you're taking what b is equal to, which was 4a, and you're plugging it into where b was in the equation, okay? So we would get 2a plus 4a equals 24. Next one, we've got if x over 3 equals 12, then x equals 36. This is the multiplication property of equality. And the reason it's the multiplication property of equality is because what we did here was we took x over 3, we multiplied this side by 3, and then we multiplied the 12 by 3, and we got x equals 36, okay? That is the multiplication property of equality. That just says that if you multiply by the same number to both sides of an equation, you're going to keep the equality. All right, example 2. So we are going to solve these problems and justify each step, okay? So each step, this is the first step, so we're gonna write this first one as what's given. The next step is they multiplied both sides by 3. So that would be the multiplication property of equality. The next step was they distributed this 3 to both terms on the inside. That would be the distributive property. And then next, what they did was they added 12x to both sides. In doing that, they used the addition property of equality. And then lastly, they divided by 14 to both sides. That's the division property of equality. And that's how they got x equals 27 over 14. So normally, this two-step equation we would have done just by, you know the steps, multiplying by 3, dividing by, or adding 12x to both sides, and then solving for x by dividing by 14. But now we have to justify each step that we're using a property of equality. All right, so example 3. On. We've got 3x plus 2 equals 23 minus 4x. Justify each step. So in your homework, when it asks you to do these, normally we don't ask you guys to justify each step, okay? But instead, I want you to label statement and then the reason, okay? So for justifying each step, this is how, in your homework, when it asks you to do this is how I want you guys to set it up, all right? So for the first one, we're just going to rewrite what's given. So it's 3x plus 2 equals 23 minus 4x. This is what's given. Now, the first step that we should do is we should add 4x to both sides, and that would be using the addition property. I'm going to rewrite property of equality as POE, okay? So when we add 4x, this is 3x plus 2 plus 4x equals 23 minus 4x plus 4x. That's the addition property of equality. The next step would be simplify. So this 4x and the minus 4x cancel. The 3x and the 4x combine to give us 7x plus 2 equals 23. Next, we're going to subtract 2 from both sides. This is the subtraction property of equality. Okay, because we are subtracting from both sides. After we do that, we will be left with 7x equals 21. This is a simplify step. And our last step would be divide by 7, which is the division property of equality. And that will give us x equals 3. Okay. Example 4. Solve for r in the formula p times r plus 1 equals n. Okay. So now we've got multiple variables. We're not going to plug in anything for the variables. We're just going to try to get r by itself on one side of the equation. Okay. So what we're going to do is we're going to first rewrite it. Oops. So it's going to be p times r plus 1 equals n. This is what was given. Okay. And our first step will be to distribute that p to the inside. So that's going to be like this. This is pr plus p equals n. This is distribute. Distributive property. And then from here, what we want to do is subtract p from both sides. When we subtract p, that's the subtraction property. property of equality, POE. Once we subtract P from both sides, we're left with PR equals N minus P. That was just a simplify step. And then from here, we're going to divide by P to both sides. Because remember, we want to get R by itself on one side of the equation. And what we're left with is R equals N minus P over P. And this last step was the division property of equality. Okay? So guys, you could absolutely solve this problem just by doing the steps on the left. But the purpose of this lesson is to justify each step that you're using. So make sure that you're writing the property of equality or what you're using in order to move from one step to the next. All right, and our last example, example 5. You reflect the beam of a spotlight off a mirror laying flat on a stage. As shown, determine whether the measure of angle DBA, that's this one, DBA, is equal to the angle EBC, which would be from E to B to C. That's this angle right here. So we have to find out whether they are equal or not, okay? So I can tell that DBA I should not write that in blue. That was our green one. Sorry about that. Let me take that away. So again, that was our green one. That would be DBA is equal to angles DBE plus the measure of angle EBA. Okay, and then our blue angle, which is EBC, is equal to EBD plus DBC. Okay, now the problem does give us one piece of information that is super helpful, okay? And that is that these two angles, angle 1 and angle 3, are equivalent, okay? So in this case, angle DBC is equal to the measure of angle ABE. Okay? So now it's determining whether these two are equal up here. So what we're going to do is we're going to take what we found for them and we're going to set them equal to each other. So in this case, it's going to be angle, the measure of angle DBE plus the measure of angle EBA is equal to the measure of angle EBD plus the measure of angle DBC. Okay, so now what we do know is that DBC, this one, is the same as measure angle ABE. So let's go ahead and plug in ABE or EBA. So this becomes measure of angle ABE and now EBA and ABE, they're the same angle, guys, okay? So that's just this angle written as a different way. It's written as EBA or ABE. So if we were to subtract this from both sides, okay, we would be left with 0, okay? Because these are going to cancel from both. So then it's going to say the measure of angle DBE is equal to the measure of angle EBD. And these are also the same angle, okay? They're just written in different forms. So if we can check them off saying that this is yes, this is true, therefore our original statement, which was this, is true as well. So yes, they are the same measure. Okay. Know if you guys have any questions. All right, and here's your homework. You have number 3 through 39 odd. Good luck.